Okay, picking up where we left off on page 200, we're talking about the real purpose for this data, documenting in your data dictionary the flow. And I mentioned that, again, one of the reasons you're doing this is when you're done, you're providing all the information that your database guy is going to need to build a database and actually be able to tune it to be able to handle the type of volume of traffic that you're talking about. Okay, the next one in the data dictionary is the data store. This is where the book kind of goes into deep weeds. I would not normally get into individual fields and talking about documenting exactly what the record looks like at this time because I'm a system analyst, I'm not a database guy, and the database guy is going to look at that and go, let me handle the logical database view, please, rather than having you do that. But at a minimum, you need to have a name for these guys. And again, the whole point of this data dictionary is if you already have a name called, student data for a data store, don't create another one called student data. One of the points of a data dictionary is to make sure you don't have name collision, that you call them different things. Okay, so a description, some attributes, and once again, some volume and frequency data if you can get some estimates on how to do that. On page 202, they talk about documenting the processes. And once again, this is straightforward. We're talking about just going to the little diagram and putting in a little bit more detail. The process name, the description, the process number. So now everything is in this little model. Basically, you have, entities. I forgot entities. On page 203, they have the entities. And once again, it's the entity name, a description, and basically which way the data is going to be flowing from an entity. So that essentially, it records everything dealing with your DFD, everything in your data flow diagram. Now they talk about one more feature of this data dictionary, and that is the ability to produce reports, which is pretty cool. I want to be able to search for, the name of something. So yeah, I want these data dictionaries to be in electronic format. I want to be able to do reports. So, all sorts of interesting things. An alphabetized list of the data elements, describing each data element, indicating which user or department is responsible for it. That's very key. Oh, by the way, here are the ones that you're responsible for, accounting department. And okay, sales department, here are the ones that belong to you. That'd be kind of cool. Then, detail reports showing all the characteristics. So the reporting capability of these case tools are actually pretty cool. Okay. So let's say we're going to drive down a little bit deeper into these processes one more time. So on page 204, they talk about the process description tools. And there's three techniques that they talk about. They talk about structured English, decision tables, and decision trees. And then later on, we're going to be using the same technique for doing object-oriented programming. But that's an entire chapter, so there's no need to talk about that here. So whenever you're dealing with any one of those three techniques, the structured English, decision tables, or decision trees, they're basically only three techniques, or three modules, so to speak, that you can use to put these things together. And if you've taken the CIS389, the Programming Logic and Design, you probably remember a little bit about this. Based upon sequence, where you can describe, this has to happen, then this, and then this. That's a sequence of things that has to happen. And then a condition, or a branch, or a selection. They call it selection here. I've heard it called condition almost everywhere else. Where if something comes up and there's a fork in the road, and you could go to the right or you could go to the left, depending on some condition. And then, of course, you have looping. So no matter what programming language you're dealing with, you could be working with assembly on a supercomputer, or you could be working with Visual Basic, and they all still can be described using combinations of those three things: sequences, branching, and loops. Okay, so now that we got that part out of the way, Now we can actually talk about how to use structured English as an example. So on page 205, they talk about a way to describe how a process works. And basically what you're describing is what I would call the business rules. So for example, I'm doing an order fulfillment thing, and I have to know, is the credit card number valid? Boom, number one. So number is valid. Check. So that's one of my rules. Before we go any further, I have to know if the credit card number you typed is valid. Boom. The next one, did the credit card process go through? Perhaps you don't have enough money, or it's been tagged as stolen, or whatever. So in other words, that's another rule. Boom. And so you decide these rules, and then you write using structured English. If credit card is valid, then do something. And if the credit card transaction is approved, then do something. If it's not approved, then do something else. That's structured English. And it looks an awful lot like pseudocode if you took some of those early programming classes, and that's because, quite frankly, it is. Structured English really is pseudocode. And they recommend in the book that you just use very few number of phrases. Don't invent new words over and over again. So it doesn't make for very entertaining reading, but it's designed to describe things in minimal terms. Anyway, on 205, you can see some examples of that. The next one on 206, they talk about decision table. If things like I just explained to you about, okay, the credit card number has to be valid, and then the transaction has to go through. That's pretty straightforward. I mean, you can kind of tell that if both of them are yes, well, then you're going to be able to buy that product, right? No-brainer. If any one of those is no, well, then we just stop there. So, it don't take much brain power. But there are times when the rules are extremely complex, and it's helpful, perhaps, to draw them out using a decision table. Okay, so on page 206, they have an example of one that's kind of sort of simple. Okay, this one is, here are all the possibilities. The credit status is okay. You're verifying an order. So the credit status is okay. And so we have, yes, 2 yeses and 2 nos. There's only 4 possibilities, right? And the product is in stock. So if the credit's okay and in stock, then yay, we accept the order. And if anything else is wrong, either the credit is not good or it's not in stock, well, then we don't ship the order. Now, again, this one is incredibly simple. I mean, it's fairly obvious. We don't really need, a decision table to figure this one out. But then, if you skip ahead to page 209, let's look at one that gets a little bit more complex. So let's talk about this one, where, okay, the credit is okay, product is in stock, but you could get a waiver from a credit manager. Okay, now you're getting a little complex. And they, instead of having too many of these things, they actually took these 8 combinations and kind of squashed them together a little bit. So now it's a little bit more complex. Not terribly, but we're kind of sort of getting there. So this one I kind of thought, well, okay, yeah, we probably do need a decision table because it is getting a little complex. Okay. The one on the next page is the one that's the most complex, and it is super. I mean, it talks about whether or not you get a discount, and if you're a preferred employee, and you ordered over $1,000, and it gets a little mind twisting there, because you have multiple rules that apply. Do you get double discounts if you qualify here for 5% and qualify here for 5%? Do you get 10% discount? Anyway, in that table is a bit tough. Now, I will tell you, if you skip ahead to page 210 and look at that exact same diagram, but as a tree, so a decision tree. So the diagram on page 210 shows the exact same thing. I personally like the tree better. I can look at the tree and immediately tell what's going on. If you flip back a page, look at that table, you go, you kind of squint a little bit and kind of grunt and go, ugh. Let me see. Okay, if I do this, and this. But on page 210, whew, maybe it's just me, but That tree diagram is incredibly simple. It's just a very simple yes, no, more another yes, no, another little yes, no. And at the end of the tree, it tells you what discounts you actually get or whether you get any type of special treatment at all. So I prefer the decision trees because, again, this really isn't for you. Not really. This is designed to be a tool that you can use to describe the system and communicate this to others. And so you're communicating this with the customer that's hired you, and you're saying, okay, is this the rules? And if they can't figure out your diagram, they're going to look at it and go, yeah, it looks good to me, right? But if you make it simple enough for them, they're going to look at it and go, oh, yeah, you're right. Yeah, if you combine these two together, you do get this, this, and this. And so, again, the diagram is not for you. It's to help communicate these complex topics to these other folks. Okay, we are almost towards the end. On page 211, they talk about, briefly, about the difference between a logical model and a physical model. Up to now, we've been doing logical models. And the logical model just talks, again, we've said this before, it's all about, what's actually going to happen, but not how it happens. The how is the physical model. And so the physical model shows, when you're done, is going to actually come up with the system requirements. In other words, when you're done with this and you find out what the physical model is, I'll know what kind of database server to get and all the rest. I'll know everything when I get to that point. There's this thing they talk about is what they call the sequence of models and this 4-model approach. Now, one of the things they talk about is, let's say that you're replacing an existing system, but you don't have any real documentation. Not that kind of this kind of documentation. You don't have this kind of documentation, but you do have a physical system. So you can create a physical model and then backtrack from the physical model and generate a logical model of the existing system. Okay? Now, you don't ever do that when you're building a new one. You don't ever start at the bottom and work up. You start at the logical model and then go to the physical. So what they're suggesting is one of the things you can do is start with the existing, create a physical, then go to a logical, and then go to the logical for the new, physical for the new. And then they turn right around and say, a lot of people don't like this because it's expensive, and they want to see progress done on the new system, and why you're spending all this time documenting the system that we're getting ready to throw away anyway. They don't understand the value of it. Again, this isn't for you. It's to help make sure we didn't miss anything, because if you don't have a well-documented existing system, you put the new system in and they'll say, oh, this is all fine, but what happened to the the such and such feature? And you're going to say, what? What are you talking about? Well, the old system had this way we could do this. You go, jeez, missed it. So again, if the system is not very complex, the one you're replacing, you could probably skip that. If it's very, very complex, maybe you ought to do it. Maybe you ought to go through and do their little 4-model approach. Okay, this is the end of the chapter, and we are going to do the normal end of chapter summary, but immediately following that, I'm going to pop out and show you some cool tricks with Visio. So, before I get into the chapter summary on page 212, this is probably a good place to stop at the 15-minute mark. So, see you again in just a few.